Hello everyone. So last week we talked about the Pythagorean acousmata and the doctrine of the transmigration of the soul, and we mentioned a bit about the relationship between mathematics and music and the doctrine of the soul, and the idea of there being a combination of mysticism and sort of mathematics and numerology and a mix of beliefs out there with the Pythagoreans. So the Pythagoreans very, very famously said, or the notion that they had rather, was that happiness, sort of, the purpose of life really consists in the knowledge of the perfection of the numbers of the soul. Right? So the idea that the soul itself has a particular kind of number, and this number, the knowledge of this number, is the path towards sort of salvation. So for that reason, I think the most important part of the doctrine, apart from their very interesting religious beliefs and their very interesting sort of superstitious beliefs, of which you have things like do not eat beans, wear the shoe on your right foot first, wash your left foot first, however, and a series of such beliefs, one after the other, some more bizarre than others, some sort of more sort of understandable in a ritualistic context. Given all that, how do we reconcile their mathematical sort of beliefs with these strange sort of practices, ritual beliefs, and religious beliefs? Well, they reconcile it by themselves, right? Their mathematics has a very sort of mystical sort of impetus to it. So when they sort of promote the sort of study of numbers, when they extol the study of numbers, what they're basically doing is that they are making number into a kind of sort of divine principle. And we'll talk about this idea of the number as the arche for Pythagoreans, which is what Aristotle says. But this idea of number as being something sort of, primary and divine and with magical properties, really. So there's a mix of, a scientific attitude towards mathematics and a magical sort of, or superstitious attitude rather, towards numbers in our modern terms, right? So, and then they related this theory of numbers to everything. And this is what, for example, Aristotle found very, very bizarre. Because what they actually did was that it was, they were not sort of just studying mathematics as a study of abstraction for the sake of sort of understanding the mathematical sort of principles of, or for figuring out, theorems, or the famous Pythagorean theorem, for example. Rather, they connected every single thing to this doctrine of numbers, so they understood everything from human life, animal life, to cosmology, cosmogony, everything, to the extent of understanding even things like, justice and harmony and man and woman, marriage, every single thing from solid objects to abstract objects, everything through their doctrine of numbers, which makes the whole enterprise a bit complicated to understand for the modern mind. And in fact, it was complicated for Aristotle too, not just for the modern mind. So Aristotle as well, in his Metaphysics, complains about Pythagoreans, and he says that, these guys I don't understand. The others I can see, I can fit them into something, right? But these guys he feels that are very strange. So he says, amongst these thinkers and before them, so he's talking about all the pre-Socratics, and he gives like a sort of proper history of the Ionians and the physicists, up to the atomists, as we are doing in this course. And then he says, amongst them, before them, through them, after them, as we said, the Pythagoreans lasted very long, so they had a long history, before, after, and they continued up till like very recent times. So whether in their interest in mathematics, were the first to bring these in, and being involved in them, they thought that the principles of mathematical entities were the principle of all entities. And since of mathematical entities, numbers are by nature primary, and among these, they seem to observe many similarities with entities and things coming into being, rather than in fire and earth and water, so that such and such an affection of numbers is justice, and such soul and mind and another time with each of these other things likewise, so to speak, and also seeing the affections of harmonies in numbers and ratios. Right? So they saw numbers in everything. So first they saw mathematics in everything, and since they considered the essence of mathematics to be sort of number theory of a sort, so they considered numbers to be part of everything. Right? Since then, sorry, I'm trying to turn the page. Since then, all other things seem to be assimilable to numbers in their nature, and the numbers were primary of the whole of nature. They assumed that the elements of numbers were the elements of things as a whole, right? So the strange idea which Aristotle himself is like struggling to put forward, that the elements of numbers were the elements of things as a whole, and they thought that the whole heaven was a harmony and a number, right? So that the whole heaven, and also the whole universe, the whole cosmos is a harmony and a number. And all features of numbers and harmonies that were in common with the affections and parts of the heaven and the whole cosmic order, these they brought together and applied. And if anything was missing, they added it on so that the whole matter should be complete for them. I mean, such as since the decad, which is the tetrachus, we'll look at that, is thought to be complete and to embrace the whole nature of numbers, and we'll explain why. They also said that the bodies in the heavens were 10, and since they're only observed to be 9, they made the anti-earth the 10th. So right, so they were trying to get everything to fit into their number idea, and they said since everything comes in 10, and the ancients believed that there were 9 heavenly bodies, so that's like Earth, planets, sun, stars, and moon. So they added an extra sort of planet for that. So there was that sort of focused on their idea of fitting everything into the idea of numbers. We have treated all this more accurately elsewhere, but the reason why we are going through this here is that we may understand with these thinkers too what they suppose the principles to be and how their views fit in with the causes they have announced. Right? And we will look more at Aristotle's critique of them. But basically, he has this sort of issue with the Pythagoreans that he says that they are almost incomprehensible, but for that then he spends a lot of time trying to understand them, also because of the influence of the Pythagoreans on Plato and Platonism, who was his teacher and whom he is trying to sort of move forward from in this book. So for that reason, you have Aristotle spend some time with the Pythagoreans, which is good because then we have a bit more, because as I said, we have no extant fragments from Pythagoras himself, and a lot of modern scholars really doubt whether he existed or not, or rather he existed, but whether he existed as this mathematical genius or not, sort of an idea is what is doubted. But with Aristotle, we have at least a lot of critique of the so-called Pythagoreans, as he says. And again, he doesn't name Pythagoras per se in this one. What he's saying is Pythagoreans. Yeah. So we've talked about the general beliefs, which is the acousmata. We've talked about the immortality of the soul. We've talked about the idea of the universe as being one, eternal, divine, and we'll hone in on this idea of the one or the unit. And we've talked about the cycle of transmigration. So now we are looking for this bridge between the religious and philosophical ideas, which was the idea of the world as a cosmos, which is the world as something which has order and beauty and structure, and this cosmos then the Pythagoreans understood in ways which are a combination of that's why there's a lot of argument. So Aristotle would say, and I'll read out a bit more from the same text, where he says that they promoted a kind of dualism of things, right? They divided things into two parts, a kind of yin and yang kind of an idea, and promoted the idea of the difference between what they called limit or peras, which is the boundary, and the unlimited or aperon, which sort of breaks that boundary. And so for them, what was most important important was this dialectic between the limit and the unlimited, which are the two contrasting principles from which they believe the whole universe evolved, right? So the unlimited keeps growing and growing and growing because it's apeiron, right? It has no end and it sort of expands. And the limit sort of hones in and stops it from and gives it some kind of a balance and gives it some kind of a harmony, right? And remember, for them, harmony and balance are good things, and so the limit is a good thing, and the unlimited, which is disharmonious, is a bad thing. And we'll also talk about the very important idea of music that sort of influenced the number theory. In fact, I think music is the biggest influence on the Pythagorean number theory. And in fact, with music as well, you have this idea of sound as a continuity, right? Sound is continuous and continuous and continuous, and you have a continuity of sounds. If you've ever played a musical instrument, and especially if you've ever played a string instrument, you'll notice that every single point of the string, no matter where you press, and if you sort of like bend it, you will have a continuity of like bending sound, if you want to think of it that way. It's sort of a bend of sound. And for example, if you bend a string in a guitar or a sitar, which I play, in a sitar. So for example, if you have one note, let's say you have a C, you can bend it to go to the G, which is higher than that C. And in that bending, instead of like if you do it staccato, if you go from C to G, if you jump from it, you'll just jump from C to G. But you can also bend it, and you have a continuity of sound between C and G. Now, the C and this G, both of them act as limits, while in the middle it is unlimited, right? You have an unlimited sort of division of sound in the middle with quarter and subquarter and whatever, the notes that are playing, the pitches that are playing in there, and you have the limited pitches in between, right? So for them, music was actually one of the biggest influence in thinking about this limit and unlimited, and we'll hone in, as I said, on their notion of music and how that music sort of influenced their mathematics. But this limit and unlimited part, so I'll just sort of read out the next part from the same text by Aristotle, Metaphysics Alpha 5, where he says, well, even these thinkers seem to hold that number is a principle both as matter for things that are and as affections and dispositions, and that the elements of numbers are the odd and the even. So there are two things that are elements of numbers, the odd and the even, and that of these, the one is limited and the other unlimited, and that one is from both these, since it is both even and odd, and that number comes from the one, and that, as we have said, the whole heaven is numbers. So pretty complex, and we'll have to really try and figure out what's going on. So there are two kinds, right? There are two kinds of numbers. One is the odd number, and one is the even number. And then they connect the odd with limit, with peras, and the even with unlimited or apeiron. And then they say that the unit is both odd and even, so it both is limited, it has peras, and it is unlimited, it is apeiron, and we'll see why that too. And then the whole heaven is numbers, right? And then they put them into groups, and Aristotle makes these sort of groups out here, which I'll share in the interactive session. I think that would be better for us. So these kind of groups, in which he says, so you have two parts. You have the limited, or the one with peras, and the apeiron, or the unlimited. The one with peras or limits has even numbers. And it has it is sort of even, it is contained. So you have this Aristotle's list says limited, even, one, right, male, still, straight, light, good, square. Unlimited, odd, many, left, female, moving, bent, darkness, bad, oblong, right? Now, this is actually a fairly confusing list. So let's try and think of what's going on in this list, and maybe that will give us more of an idea of what is meant by Pythagoreans. So we already understood that they have two concepts, of one being things that are limited and one being things that are unlimited. Now, when they're talking about numbers, they are talking about a kind of combination of geometry and arithmetic, really. So even when they talk about geometry, you'll notice that they are talking about geometry in terms of numbers. Yeah, rather than talking about geometry as people would have done in that time in terms of shapes, but they talk about it in terms of numbers, right? So now they're placing 1 as the one with the, or rather the odd as the one which is within pairs, and the even as the one which is sort of, not in pairs. Sorry, here it says the opposite, but like anyway. Why is that? And there's a diagram in Kirk and Raven which actually sort of explains it very, very well. But yeah, if I can find the diagram. So you have, and I'll share that diagram in our class when we do the interactive session, because it's very difficult to draw diagrams in this live video sort of session, where he explains how geometrically, if you take the number, for example, if you take the odd numbers, and let's say you put them in terms of each unit as a dot, right? So you have 1. Then 3, which they liked very much because they said 3 has a beginning, a middle, and the end, right? That's why it's in pairs, it's in limits, is because you have 1, and then you have 3 is sort of 1, 2, 3, right? So it forms a square sort of a thing. And it has a beginning, a middle, and an end, right? And it'll be equal-sided, the 3. Like a triangle, except right now we're looking in right angles, right? Then the number 5 will again form a square. A number 7 will again form a square. While if you look at even numbers, what happens is that every time we try to form, so we have, let's say it begins with 2, right? So 2 already is sort of, a line like this. And then the next number 4 will go, like this and half. Right, half the length, so which means it will become an oblong or a rectangular number. So that means that the middle of it cannot be found. It has a beginning and end, but it doesn't have a middle, right? Which means that it is, if you try to subdivide it, if you try to subdivide any of the odd numbers, you can find the center of it, in geometrical terms, and the diagram will help you see it. So because it forms squares, these keep forming these square kind of things. So you'll find you can draw a straight line from the middle and you will find the center of it. While when you look at even numbers, the center you will not find, right? So you can try and sort of cut it from the middle in this triangular shape, and you'll find an irrational number, really. So you try to cut it and you'll find an irrational number. That was the problem, for example, with the square root of 2. Later on, which they found. So they didn't really, when they discovered that, they were looking at this triangle made of 2 units, and they said, 1 unit, then what is the length of the hypotenuse? And they discovered that it would be the square root of 2, which is a number that they could not find. And then they were very sort of disturbed by that whole experience, I think. So that meant that it was unlimited, right? It was something which would lead to an irrational, unlimited series of numbers. They would not be able to find the center in that sense. So that's the idea. I mean, I know I'm not probably explaining it as well. We'll try and do it in the interactive session where we can look at these diagrams and see where they're coming from. In fact, there's a story that Hippasus of Metapontum, who was one of the followers of Pythagoras, so apparently, because remember, these kind of mathematical beliefs were to be kept very secret. So he went and revealed, this irrational or incommensurable number that they found in these geometrical quantities, that they found that these cannot be expressed in terms of whole numbers. And then the story goes that either he was expelled or he was punished by the gods and he perished at sea. So there are all kinds of stories that go around about this. But we also then have an idea that they did discover this irrational number and they could not deal with it and they didn't like it. And they believed that this irrationality really comes from the apeiron, and this apeiron is related to even numbers. And because it has no telos, it has no end, it has no middle, it has no balancing point as well, right? So an oblong rather than a square, let's say. So the good odd limited number is a square. It has a beginning, end, middle. Number 3 they really liked for that reason. While this apeiron evil number, had no end. But then on the other hand, they also said that the unit, for example, was both odd and even. So the section I read out from Aristotle, where they talk about the unit, and then you also have this this thing. I'll read out another section where they talk about this. So this is from from the later Pythagoreans, really. So the first division of numbers that they make is into two classes, calling them some even and some odd. Even numbers are those which can be divided into equal parts, and odd those which can be divided only into unequal parts. We are looking at it in a different way. Some held that the first of the odd numbers is 1, for even is the contrary of odd. 1 is either odd or even. It cannot be even, for so far as from being divisible into equal parts, it cannot be divided at all. Whence it follows that 1 is odd. Again, if you add even to even, the whole is even, but add 1 to an even number and makes the whole odd. Whence it follows that 1 is not even, but odd. Aristotle, however, in his work on Pythagoreans, says that 1 partakes of the nature of both, which is what we saw earlier. For when added to an even number, it makes it odd. When added to an odd, even, which would be impossible if it did not partake of the nature of both. And so he says it is called even odd. Right, so you can see the two versions of the same thing, and you see the whole Pythagorean sort of system. There's so much confusion because we're looking at many centuries of people who are all pondering about the same thing, and they're trying to decide weird things like, is the number 1 an even number, an odd number? And then later Pythagoreans are saying it's an odd number. But then the earlier Pythagoreans who believed that any number should contain an element of the number. If you add it and if it changes the character of that number, then there must be it must contain some element of it. So Aristotle is promoting this one understanding, but it doesn't mean that that all the Pythagoreans did believe it. And in any case, we don't really know what exactly they believed, right? Yeah, and we'll look at some of the idea of the geometrical sort of structures coming out from numbers soon, probably in this video or the next. But right now I want to really sort of focus on this idea of limit unlimited, because it's again from this that everything then evolved. And remember, they also tried to connect things like man and woman to this. So they said things like the man is a number 3 and woman is a number 2. Now, some people make a joke of it and say this is a very crude way of talking about the biological differences between men and women. But there is something out there which the Pythagoreans are doing, in which they're trying to talk about this limit and unlimited in sort of perhaps in a societal sense of in that society, so the place of the men and the women, and that the women were placed in pairas because they apparently were apeiron. This kind of an idea was sort of promoted in that time, which makes them sound like terribly sort of unfeminist and horrible. But the society was such. And interestingly, the Pythagoreans were the first people to actually allow women in their ranks. And Hypatia, for example, was a Pythagorean, and she is one of the earliest mathematicians we know of, and she was a woman as well. So the fact that they allowed sort of women in their ranks, and the women could be teachers as well, they could be Pythagorean gurus of a sort. So that is a step forward. And Plato, influenced by Pythagoreanism, also said that women should be allowed to govern in the Republic. There's nothing in women that stops them from governing. So this whole sort of, as I said, a confused set of beliefs, right? Anyway, so the world, when they talk about it, the cosmos, it is something that is a complete whole, right? It is a thelion, it's something that has limits, and it's because it has limits that it is well ordered, it is structured, it shows regularity in its cycles, it shows regularity in the cycles of day, month, year, etc., etc. And that's why Pythagoras is said to have been one of the first, or the first person really, to have applied the term cosmos to the world, a good, beautiful order, and the Pythagoreans to have used this term, and then this caught on with all the other philosophers. Plato in Gorgias, for example, sort of says, heaven and earth, gods and men are bound together by kinship, as we saw already with the doctrine of the soul, and love and orderliness and temperance and justice. And this sort of idea of like temperance, justice, order, and limits, really, sort of, and kinship that connects the whole world. So the idea that the universe is a cosmos pervaded by divine life, divine reason, and we are cosmoi in miniature, and by active intellectual study we can get to the salvation, to the complete one of the universe, and the idea that numbers, which then have mystical significance and are what are responsible for harmony, As you saw with the limit and unlimited, even with my confused discussion, and the confusion is not just from me, it is in the actual sources there's such confusion, right? So the numbers as being responsible for harmony, which is the divine principle, and harmony, remember, is the idea of joining together, of things joining together and becoming harmonious. And we'll see this idea turn up later on, and we'll see it with Heraclitus, and we'll see it later with Empedocles, and I think also with Anaxagoras. We'll see it with the atomists. So the idea of harmony as sort of joining together, which is what it actually means, this harmony then comes from numbers, which govern the whole world, right? And that's why numbers explain not just the physical world, but also symbolic sort of world. So, for example, justice was thought of as the number 4, or the number of reciprocity, which is a square number 2. But then there was another idea that justice was the number 5, because it's the balance between the odd and the even, right? The number 2, which is the first, in that sense, properly even number, and 3, which is in that sense the first odd number, because 1 we are excluding as something that we don't know the status of, right? So the unit is something that's a bit more confusing for them. But the number 2 and the number 3, they know is the first even number, the first odd number, which is the unlimited and the limit, or the other way around sometimes, right? The addition of these numbers would be the number 5, because then the number 5 sort of shows, reflects rather the balancing of the limit and the unlimited, the balancing of two opposing principles. And the idea is that you have two opposing principles which are contrary, and justice is the balancing of contraries, or the harmony of opposites. And this idea we'll see in Heraclitus as well, but the sort of attunement and harmony of opposites, so that would make justice a number 5. So you will see that they have some vague numerological logic behind these ideas. So they're not completely out of the blue and saying strange things like this number means this kind of a thing, but they try and produce some kind of a logic to it. And they also say marriage, which is sort of, the marriage between a man and a woman would be number 5, because one of them is number 2 and one of them is number 3, the unlimited and the limit. So in that sense, mathematics would have a metaphysical significance, in which we see is also there in Plato. When you look at Plato's sort of Republic, or many other texts, you will see that this idea of, he is being a bit more serious about numbers, but he still has this notion somewhat of this metaphysical significance of mathematics. And in fact, in his Republic, when he gives his educational program, it's a completely mathematical educational program. So people learn by studying arithmetic, then they move on from arithmetic or sort of understanding just basic numbers to understanding geometry, and plane geometry, that is, like lines and triangles and squares. Then they move from plane geometry to solid geometry and try to think about objects and cubes and cones and things. Then from that, they move towards astronomy, and astronomy is sort of, the movement of solid objects in space. Then they move from astronomy to music, to harmonics, which is the sound that is created when solid objects in space sort of interact. So you have this sort of, and these are all related to mathematics, and that's why they all contain numbers in that sense. And and that's why when Aristotle out here, when he says that things themselves are numbers, and things imitate or represent numbers, and the elements of things are the elements of numbers, and the whole cosmos is a harmony and a number. This is what he means, and this is what he means when he really this discussion is a discussion of arche in the beginning of metaphysics. It's on the first principles, and so for that reason he sort of posits that the arche of the Pythagoreans are numbers, because numbers are what compose the cosmos. The whole cosmos is composed by the putting together of numbers. To conclude, we'll do a bit more about the number theory, but to conclude, I would like to talk a bit about their idea of about how music is related. Remember, music is also the highest study of mathematics, right? So you start with arithmetic and plane geometry, solid geometry, astronomy, and then you eventually get to music, right? And music is the most complete study of mathematics. And after that, Plato would posit something called dialectics, which is sort of talking about and putting everything together. We'll skip that one because you're looking at Pythagoreans. But music is also the initiation of mathematics, right? So when they talk about harmonia is the idea of joining or fitting together, but it also means the stringing of a musical scale, you know. So the stringing of an instrument is also called harmonia because you're fitting it together. If you've ever tuned an instrument, you will see how, you know, you're sort of moving that sort of like that joining part, like the string connected to the wood. I mean, I'm talking about my sitar actually, and then you turn it around, and then the string sort of gets this tension, and it produces a particular sound. So it's an action of joining things together. So the story actually goes, and I might have mentioned it in the previous class, I don't remember, that the Pythagoreans were walking around, and they were, Pythagoras, was walking somewhere, and he heard the blacksmith, sort of from the blacksmith's workshop, he heard different sounds. So he went to investigate how was he producing these different sounds. So the idea was that he was hitting different pieces of metal and making different kinds of sounds, and then he realized that, you know, the sort of proportions of the pieces of metal led to different sounds being produced. Now, there is a lot of disbelief about this story. Like, people say that the more likely idea is actually of string instruments, which existed at that time. So the ancient lyre, or the ancient guitar, if you want to think of it in those terms, had all these sort of like, would have all these strings attached at different lengths. You know, so at different lengths, and all the strings would produce different sounds, and they measured, and that measurement was possible. So they did a ratio, a logos, really, you know, of the instrument, and they discovered that there was a correspondence between mathematical ratios and concordant intervals of the scale. So they discovered that the octave was in the ratio of 1:2, right? The fifth, which is, you know, if I could do it. Yeah, I don't know if I did it properly. Anyway, and then the fourth. Right. So these are all. This is in ratio of 3:4. So they discovered that, you know, and this was the rate of the vibration of the spring was dependent upon the length of that string and the tension at tension, of course, but at the length at which it was sort of fixed. So they discovered that there was this concordance between, and then this correspondence rather, between the length of the string and the sound that they produced. And this ratio, more interestingly for the Pythagoreans, contained the numbers 1, 2, 3, and 4, right? 1:2 octave, 2:3 fifth, and 3:4 fourth, right? So the perfect intervals, as they are now called, they were all sort of, you know, in this ratio of 1:2:3:4 kind of a thing. And if you the tetractys that they made, which is the number which they think of as the best number ever, and I'll just read out something about it, is composed of these 4 numbers, right? So if you think about it, I'll share it in the interactive session. So if you put a point at top, 1, then 2 below, then 3 below, then 4 below, you'll get this triangle, and 1 plus 2 plus 3 plus 4 is the number 10, right? So 10 points, and they believe 10 to be the greatest number, the highest number. So they said something like, 10 is the very nature of number. All Greeks, and wait, I'm just trying to find, so this is our ATS, yeah. So 10 is the very nature of number. All Greeks and all barbarians alike count up to 10, and having reached 10, revert again to the unit. And again, Pythagoras maintains the power of the number 10 lies in the number 4, or the tetrad, right? Why? This is the reason. If one starts at the unit and adds the successive numbers up to 4, one will make the number 10. And if one exceeds the tetrad, one will exceed 10 too. If, that is, one takes the unit, adds 2, and then 3, and then 4, one will make up the number 10. So that number by the unit resides in the number 10, but potentially in the number 4. Yeah? And so the Pythagoreans used to invoke the tetrad as the most binding oath. So when they took an oath, they said, "Nay, by him that gave to our generation the tetractys, which contains the fount and the root of eternal nature." Right? So this idea of the tetractys containing the fount and the root of eternal nature. Then they also had this very sort of, and the other one was the notion of, the famous one, which I will stop by reading this out, is the Pythagorean theorem, which a lot of people say was probably not Pythagoras at all, but much later by one of the later Pythagoreans. So, but attributed to him, which is the square on the hypotenuse of a right angle triangle is equal to the sum of the squares on the side enclosing the right angle, which you've all done in school, so you know what this is. The rest of the sentence, the rest of the text says, if we pay any attention to those who like to recount ancient history, we may find some of them referring this theorem to Pythagoras and saying, he sacrificed an ox in honor of his discovery. Now, we don't know about this because also he did not want to, if they banned animal sacrifices, so we don't know how this works out. But you see the level of confusion that we are capable of when we talk about the Pythagoreans, or at least I am capable of when I talk about the Pythagoreans. So we have the idea of numbers as being centrally important, as being a sort of arche, if we are to believe Aristotle. We have the idea of cosmos as being order and beauty, which is imposed upon the chaotic range of sound, because we're really talking about sound and music, by means of this first 4 integers, 1, 2, 3, 4, which then add up to the number 10, which makes a perfect number, which contains in itself, as I say, the whole nature of number. And then this becomes the root, as he says, root and source of everlasting nature. And then this tetractys with these 4 sort of, 1, 2, 3, and 4, it forms a sacred symbol. So what you have out here is really, really a number mysticism, but combined with some genius mathematical advances. It takes a lot of complexity to think of the relation between continuity and limit, and to think of the relation between sort of, between different numbers and ratios of a musical scale, and to think of them in terms of number theory, really, right? And to think of numbers really as not properties of substances, but as themselves substances, right? It's not that this number, I have 10 apples, I have 10 mangoes. It's not that sort of a thinking of numbers, which is a very sort of naive, basic thinking of numbers, and which is what we would expect. But to think of an object itself as being composed of numerical proportions, of being made out of numbers, and numbers as the cause of the reality of things. And so the Pythagoreans, we will see, are and we are looking at from 6th century BC to 5th century, 4th century, and onwards, develop this kind of a very interesting tradition of numbers, and then they answer to people. And I'm covering some of it before Parmenides, but once we get to Parmenides, you'll see what they are also answering when they come up with something called number atomism, which we will discuss in another video. And the idea of things being composed of numbers, as Aristotle says, when Aristotle says that all things consist of numbers in the literal sense that physical bodies themselves are made of numbers, and Aristotle doesn't have much patience for that idea. But we'll see what the Pythagoreans are responding to, and in some ways, it's genius, and in other ways, it's completely incomprehensible and mad. Perhaps the two do go together. Often enough they do. Anyway, thank you. Thanks a lot.